Okay, this setup started as a little pulse motor, but by mistake I've come up with something else. So just going to show you what we've got here. Just a couple of coils, about 130 ohms each, fine wire, lots of turns, two of our 1.2 volt batteries which I've run down. About 2.271, 2.27. So just our basic 2N3055 transistor and a little LED, but to get it going I have to leave the LED disconnected. So we're running off one battery and we're coming off the collector through a diode, through another diode being our LED, back into the second battery, and they're hooked in series. We've got our voltmeter across the two batteries and our current for the system will be drawn from one battery. So it's a little tricky to get going. So I'll hook up our amp meter, and as you can see we're set on 1 volt divisions here, and 50 microseconds on our time divisions. So this might be a bit hard one-handed, but oh no, I lost it. Here we go. Now I've got to keep the magnets in the right spot. Okay, that's what we have there. So now we can hook our LED up, and because we had 5+ volts there, we can run it through the LED and still charge our 2.4 volts. And that is our waveform across there at the moment. That is our current draw. Nothing. That is to the 3rd decimal place, so down to 1 milliamp. So it's drawing less than 1 milliamp. And that is our combined battery voltage. And of course our little LED is running away there. So quite interesting. Not really sure why the battery voltage is going up when we're running an LED as well. So their starting voltage, they've been resting for about 15-20 minutes. So they were pretty much well at their rest voltage. Interesting. The LED is not very bright, of course. Well, it's not too bad. It's a small one out of a garden light, one of them solar garden lights, as are the two batteries. They're only $1 each. You get a rechargeable battery, LED, and some stainless steel tube, which is good for other experiments. Also get the nice little circuit that's in there as well, which we've played around with before. I have had this running about an hour before, and we've got the batteries up to 2.52 volts. So just seems to keep charging. Then discharge the battery, start again, and if I leave it running long enough, they will charge back up to that voltage while running the LED. So I've eliminated any voltage coming in from the scope because I've had that disconnected and the voltage still rises. I've disconnected both meters and just let it run for 15 minutes, hooked them back up, the voltage still rose, so there's no power coming in from the meters or the scope. Here's a really interesting bit. If we do that careful enough, we can remove the magnets. It still runs. It still continues to charge. We can remove our trigger coil wherever we like. Still continues to run. So that coil there is nowhere in the field here. So interesting setup. Very simple, but seems to just keep lifting the battery voltage for some reason. You can flatten them out time and time again. It does the same thing over and over again. So don't really know what to make of it just yet. I've heard all about surface charges and the battery effect, and with the lead acid batteries you definitely get the chemical effect, but I'm not really sure that happens with these batteries. And when discharging they seem to be pretty well fully charged. So I just thought I'd make a video of that, because I've never actually had the battery voltage go up before, combined voltage. With the SSG you do get a quick surge of voltage in the charge battery, but the combined voltage will start to drop after a while, but this one here just keeps climbing and climbing. And we can now disconnect the system. As you can see, it has stopped, and the battery voltage will stay where it is. Okay, well that's it from me. Cheers guys. What I've done here, just to eliminate the scope from the equation, I've just hooked the scope up to its own separate coil. I now have what would be the trigger coil facing what would be the run coil, and I just wanted to eliminate the scope from the system altogether. As you can see, it's not doing anything at the moment, but if we place it behind our trigger coil, that is what we have. Beautiful ringing. I haven't touched the batteries since we started in the last video. They are still climbing in voltage. The LED is now brighter since I brought the trigger coil closer to the run coil. Our current draw is still 0. So interesting and very simple. The circuit is simple. Just our 2N3055. I think it was 163 ohm resistor. You could probably put a pot in there, just a 10 ohm resistor and a 500 ohm pot, have a play around with that. But it's working. Pretty cool. And our battery voltage continues to rise. So we've eliminated the flywheel. I can actually start this now just by getting a screwdriver and shorting the emitter to the collector. Give it a little kick and off she goes. But very neat and tidy on the waveform. So could probably even put a well, no, I couldn't. I'm on 0.1 on the voltage divisions and 0.1 milliseconds on our time divisions, and of course the probe is at 1 times, so there wouldn't be enough voltage there to run a LED off of that coil, unless of course I maybe brought it closer to the trigger coil, or maybe even if I just cut the backside of the former off the run coil, the backside of the former off our scope coil, and place them close together, I may get enough voltage to drive another LED. But there you have it. That's how far the battery voltage has come up since I started the last video, or the beginning of this one. I'll just merge these two together. Interesting. Okay, we're going to try a little something here. I'm going to turn the main isolator off to the shed. Everything goes dark. And the old trusty torch here. The light's still going. We're just going to see if the voltage still goes up without any AC floating around the shed. As far as I can make out, that'll be the only source. Oh well, it's still going up in voltage, and the power is now completely isolated from the shed. Okay, well this is getting interesting. You've seen the voltage of the batteries when we started, and that's what it has climbed up to. You see our little LED is still shining away there. Very interesting. Oh, and there it goes again. Okay, well this is getting... Oh, that's not the switch. Switch here somewhere. Oh, there we go. Okay, so we've eliminated AC charging the batteries. So might have to look a little further into this. It's turning out to be very interesting indeed. It actually started from a mistake. It started self-oscillating because I didn't put the diode across the base and the emitter, and I just observed that the voltage started to climb rather than fall, so started playing around a bit with the circuit, making it as efficient as I could, which was a bit hard because it's not drawing anything in here. Now one would think it'd take more than 1 milliamp at 1.2 volts to run the LED, and we don't even have 1 milliamp being drawn, and our voltage continues to rise. Mind you, these batteries started off run down at 1.2 volts each, and only hold about 1.32 volts fully charged. So it'd be a 1.6 volt total, and we are getting up there. Okay, I'll let it go for an hour or so and see how it looks. Okay, so what I've done here is decide to look at each battery individually. This one here is what we would call our run battery, which is the darker green one, and the lighter green one is our charge battery, which is this one here. This one's been fluctuating between 1.227 1.28, but it seems to have stabilised to 1.228 volts, and this one here is climbing. I would suspect it would climb a bit faster if we didn't have the LED on there. I just lifted the or dropped the voltage down on our voltage divisions. You can see all the ringing is above the 0 volt line. So very interesting. So our charge battery continues to charge, and the run battery hasn't moved. Like I said, it's been between 1.227 and 1.228. It seems to have stabilised at the 1.228, and indeed our charge battery is still lifting, and we are running our LED. And of course our current draw is zip, less than 1 milliamp. I would assume, like I said before, it would take more than 1 milliamp to drive that LED and charge the battery at the same time. So, I'll let it run overnight and see what happens. Okay, one more interesting thing I've found, or a couple. The reason we weren't getting 1 milliamp, we're now set on our milliamp scale. We've got 0.5, which is 500 microamps. At I think that one was about 1.23 volts. So that's what the system's using to run the LED and charge the other battery. Our combined voltage at the moment is 2.350, and that's annoying. So that just stopped the whole system. Give her another touch. We're away. Okay. Our frequency is 5.856 kilohertz. And those two are reading the same. This one here is hooked across our LED, and this one here is hooked across the emitter and the collector. So we have a look at the duty cycle, which will be our on time, 21.8% on the duty cycle. This of course will be our bottom spike here. It's our switch on. The duty cycle across the LED is 80.4%. So our LED is on for 80.4% of the time, which would indicate why the run battery doesn't go down and the charge battery goes up. So the bottom spike would be our 21.8%, and our ringing would be our 80.4%. But as you can see, it's not always going to be enough voltage to light the LED through that 80% on time. So that's what I have at the moment. And yes, our voltage is continuing to climb across the two batteries. Okay, well that's pretty much about it. I'm just going to let it run and see what happens.